Okay, so welcome everyone on our next lecture on the system engineering. Today we will focus on the system lifecycle management and the product lifecycle management. So let's start with the system lifecycle phases. You already know what is the system engineering about. You already have an example how important is the right now the development of the product and development of the system which will deliver the product to the final customer, and of course depend on the type of the industry. For example, airplane industry, which were given on our introduction movie, or the software industry probably right now is one of the most important part of the industry. The system development, the product development is extremely important, and we can say that it is right now one of the core and most important idea for the good business. Okay, so let's start. System life cycle phases. So we will go step by step by the phases of the system life cycle, and I hope that it shows you how important it is to understand everything which is going on in a system and how we can support the designing of the system and improving of the system by system engineering methodologies and tools. So of course we should start from the exploration of the current possible technology. If we are looking for the new product, for innovation product, we should start from the review of the current technology, because maybe some technology will be useful for our product. If not, if we don't have the current technology, we have to also work on the technology, which is of course much more difficult and it will be much more time consuming. So let's start from the exploration of the technology. There are different possibilities how to explore the technology, because mostly the technology is know-how of the industry, of the company, and it is not so easy to find out about the technology. Years ago it was invented one of the methodology which is called re-engineering, which helps sometimes to uncover, we can say, the technology which is covered in the product. And years ago it was much easier to start to assume what all activities and actions and steps has to be conducted to deliver final product. When we had final product, it was we should started from reassembling the product, and then step by step we could imagine what are the process of the production of the process, and it is re-engineering, we can say. Right now it is much more difficult because the products are much more advanced, and especially if we are talking about the non-material parts of the product, which is software, it is much more difficult to uncover, we can say, the source of the technology. So right now we can say that re-engineering could be useful, especially when we are talking about the material devices of our product. And if we are talking about services, it is even much more difficult to achieve. So how we can explore the technology? First of all, we should take a look at the all possible information which are given in the patents. Yes, so if you check the database of the patents, you should have some small information about the technology also. Then the second step, which is useful to do, is to check the current state of the different source of literature, including manuscript, papers, books. Sometimes it is first described in some papers and then it is applied into the technology. But you know, as far as it is most valuable know-how of the company, we shouldn't we shouldn't think that it will be so easy to find out about the technology. And third way to look at the technology is, of course, to try to hire the person responsible for the technology in other company. So if you are able to find out the proper person who know exactly the technology, and if your business is so much focused on the success that you are able to pay more this person, it is also a way to find out about the technology. Of course, always the company have to be safe and secure the know-how knowledge, and according to the law restrictions, sometimes, we shouldn't say even sometimes, because right now it's even always, there are some agreement between the employees, especially when we are talking about the technology owner, technology supervisor, with the time period when they shouldn't use the knowledge and know-how to other companies. But I just said what are the possibilities, and if there is no possibility to find out the sources of the technology, we have to develop the technology by our own also. So what is the next step? The next step is conceptualization. So first we have to have overall idea of our system and our product. Yes, if we are starting to designing the system from the output, yes, so I've got idea to deliver interesting new product or new service, and I started to think about how the product should look like. I have also think about the system which helped me to deliver this product. And by the system, I'm not thinking about just technology and production layer of the system, but I'm also thinking about everything else in a business which is a strong force in success of the business, which is, for example, logistics, delivery, and every activities which support our production of our product. So after this stage, we should think about overall concept of our product and our system. Then it is also a good idea to check if there are some similar companies which can be used for us as a good example. Yes, so it would be benchmarking, for example, which can be used right now, right here on this stage, to find out who is the leader of the market with our product or service, and how we can, I shouldn't say it, but how we can copy his idea of the business. If we know what is wrong in this idea and we know how to improve it, it's a good idea to do it at the start of our concept. And mostly, unfortunately, the conceptualization stage of the system life development and system life cycle is not so important, and we don't want to spend too much time and mostly too much money for this stage. And in my opinion, it is probably the most fundamental stage. So we shouldn't be hurry up in this stage. We shouldn't, always answer that we don't have money to analyze this or analyze that. We should spend as much time, and we should use good methodology to evaluate our idea, to set the goals from our ideas, and to try to find the proper way to describe the final purpose, because all those things will give us assumptions and requirements for our systems. And as many risks and many defects we will find it out on this stage, it will be better for us, because it will be less cost consuming in future steps. So what kind of methodology can be used on this stage? Probably, in my opinion, starting from my last few years of investigations, I am trying to use the SMART methodology for this stage, which is initiation stage and conceptualization stage. The SMART methodology is multi-criteria methodology of setting the goals. So if I got some ideas, yes, good ideas, we can say that everyone can be rich, beautiful and rich. but it is just ideas. Yes, if I will change these ideas into the goals, into the purpose, it's the efficiency of reaching those ideas starting to be much higher. So that is how the smart methodology is good to transfer the ideas into the goals, and also it is good to select the best idea and the best goals by multi-criteria method, including the five criteria, which is acronym of the SMART methodology, which that the goals should be specific, measurable, attractive or attained, relevant, and timelined. So at least those five criteria should be evaluated when we are on the stage of the conceptualization. Okay, so let's imagine that we did choose the best idea, and right now we are on the next step of the system life cycle. So next step would be define, design, and build. So everything which was, on the stage of imagination start to start to be more realistic. Yes, so we are starting to work on a solution. So first we have to define all important necessary information when we are starting to designing the system, which is all inputs and outputs, transformations, boundaries, environmental issue, also the feedback, and everything which is necessary to define the most important elements of the system. Then we have to go into the next step, which is designing of the system, which is probably the most difficult, because you have to get a lot of experience and even more knowledge how to design the system, to design it well, because not well designed system will not deliver the proper product. So designing stage of the system is extremely important, and we'll talk about designing of the system on our both courses, which is technical systems and system engineering. So we'll have a lot of different tools. You will receive a lot of different knowledge about how to design the system. And next thing is of course build. So after definition of the system, after designing of the system, it started to have to be built. So everything has to be transfer from the simulation, we can say our imagination, into the real world. So it is built out the system. Mostly we have to rely on cooperation when we are on the stage of the building the system, because it is not possible for even huge companies to cover all important necessary skills to build the system, starting from constructions work and finishing of softwaring, technology, designing, and logistics solutions, and so on. So on building stage, we will rely on excellence, knowledge of cooperators. Okay, so next step is integrate and tests. So after the building the system, we are starting to build every system from separate individual elements of the system. So after building all elements of the systems, including hardware, software, buildings, technology, and so on, we have to think how to integrate all those elements, and you will be given in the next semester course as integrated management systems. We will talk a little bit more about integration next year, but right now you should consider that everything has to work together as definition of the system. You already know that it's not just about the building and designing the elements, it's to find out the relations between the elements and good cooperation. So integration stage is extremely important, because a lot of problems will show under the stage of the first step of the integration, and we have to every single time test if our solutions are working well. So if we don't have any problems, or on the points when the system elements of the system has to be integrated, because probably those places are the most risky places. Okay, so next step is production. So after we did design and build our system, after we integrate all elements, devices of the system, after we test in all possible ways that it is reliable, that it is also the system is good for the production. It is without any risk of any problems. We can start to product our product, and it will be, we can say, the final test is everything is working well. Production, of course, is it's operating of the system, so it is stage after the evaluation of the system. But next life cycle phase is the production, when the system is operating, when we are talking, of course, about production system. And there is a lot of different methodologies which can be used for the production stage of the life cycle of the system, to control the system, to improve the system, or to diagnose all defects of the system before it will result is in some more problematical cases. So all those 4 stages of the life cycle cycle system, which is conceptualization, define, design, build, integrate, and test, and production. Every of those can be considered as product development phase, which is, we can say, important part of the system operating, because it would show how the product is developed, and what are the possibilities to improve product when we'll have need to improve the product, or when the requirements of the customer will change. But we shouldn't close our system when we are designing the system, when we are taking into consideration the system life cycle just on the product development phase. We have to also consider what are the next stages of the life cycle of the system. But to be honest, the product development phase is the most important for our business, because it's money maker life cycle of the system. So it is the most important for us. But we have to also consider what is after the production, which is the deployment phase, and operation and support. All system has to be supported, and has to be supported by different for example systems or different companies. And last thing, which is disposal, because every system, when we are talking about production system, has to deliver the product, but the product has to deliver the money, because all as the success of the company, success of the business, we are not considering the number of the produced product. We are considering more how much money we earn based on the selling of that product. That is how the disposal stage has to be also considered as the system life cycle. And if I would say what is the best support subsystem for this stage of the system, it will be logistics. So deployment, operation, support, and disposal, the logistics companies, logistics processes can support our system on those stages of the life cycle. Okay, so let's focus a little bit more on the product development life cycle, because I said already that it is the core of our business, that it is the money maker stage of our business. That is how we should also put a little bit more attention in the product development life cycle. Okay, so we've got also a few stages which has to be considered as the life cycle of the product development. First is business strategy. So we have to follow with our product, with our strategy of our business. Not always the strategy is that we have to earn more, we want to earn more money, but mostly it is the main business strategy goal. Sometimes we want to cover bigger market, not at the stage of the selling, for example. So we have to start from analyzing the business strategy and how we can support the business strategy by product development lifecycle. But it should be the first stage, of our product development life cycles. The second one is preliminary design. Preliminary designing of the product. So after we know what are the main goals of our strategy, after we know, for example, what are the requirements of the customers or what are the needs of the strategy, we should be designing the product, and every single step when we'll finish designing the product, we should compare if all requirements have been covered in our product. So what is the next step? The next step is detailed designing and prototyping. Detailed designing, it's everything about how to analyze what are the most important part of the product, and not just the material value of the product, but also added value of other product. We should use engineering tools for detail designing. We should support detailing designing by the proper computer system, which is computer aided designing systems, which is, for example, CAD/CAM systems. But also the prototyping, we should analyze all the types of the prototyping. We should use the proper technology, for example, starting from assessing the TRL level of our product and so on. So it is important part of product development life cycle, because there is the time here to improve our product, to check if everything is working well, to check all important components of the product. Is there available for you? Do you need to support it more? So it is extremely important stage of the product. And after the prototyping, we have to test the product and check is it is working well. But because sometimes prototypes, not sometimes, always we started with prototyping from the level when the prototype is on the simple materials in control environments. Then if it is working well, we have to check if it is also working in the real in situ conditions of our product. Next stage is integrate and test. So it is important. It is also relevant to the system life cycle phases. Why? Because mostly when we are talking about designing the product, we are designing each single elements separately, yes, and then we are trying to create few prototypes of different sub-assemblies of the product. Then we have to integrate all the sub-assemblies, all the elements into the final product, and then we are ready to test it. Because even if all tests of all prototypes of all our sub-assemblies or elements will be good, it doesn't mean that if we'll combine them together, integrate them together, they will cooperate together also well, and the final test will be also success. No, we have to always check it at least few times. So next stage is initial production. So we are starting to develop the technology of the production of our product, and we initial the first production. It is important stage of the product development life cycle, because it shows our possibilities of reducing the cost of the production, and it shows us what are the minimum final price of our product. Then we are able to compare with the current comprehensive products and check if our product will be the price of the product will be acceptable by the customer. Next stage is full production. After initial production, after learning management, during the initial production stage, we are ready to complete our full production stage. We are ready to invest in our technology, and we are ready to produce the high volume of our product. So all those steps can be considered as operations, and support has to be supported by many other different subsystems, sub-elements, the parts of our system. Everything has to be covered by our system. But we've got also outside of the system the life cycle of the product, which is the distribution and support. And as I already mentioned, the logistics and transportation processes can be very useful for consideration. Is up to us if we will use our we can say resources to distribute our product, or we will use the know-how and supply chain management from different logistic operators, for example. And last stage is sustainment. So it has to be sustainment. All our product or our phases has to be controlled and has to be checked twice. So this is the product development life cycle. As you can see, there are some similarities when we are talking about the system life cycle phases, because it has to be correspond together. Yes, system is responsible for deliver the product according to our idea. Okay, so what can be useful and what is the main idea of the life cycle of the product and system? It can be presented as the V diagram. Yes, and we'll go step by step with our next stages, which is concept development, the preliminary design, the detailed design. We are going into the stage, fundamental stage, which is built and verified. Then we've got the qualification testing, integration verification, and system validation. So as you can see here, we've got the V diagram. Yes, right now you can see Y. We've got the V diagram, and we've got some intercorrelation between the levels, horizontal levels of the V diagram. First one is concept and system validation. The test we can use the test and evaluation master plan to do it. Next level is preliminary design and integration and verification. So subsystem test plans, we have to plan, schedule all the subsystem test and deliver the information about the final verification of the all full systems. And then the last level, which is designing and qualification test. So it is product and components test plans. So we have to plan the product, we have to design the product, we have to consider all components of the products, and schedule tests for all components of the product. So that is how right now you can see the V diagram, which is very helpful when we are talking about the system engineering in combination of the system phases life cycle and the product development life cycle. Okay, what is also important, the PMTE. The PMTE is the 4 important factors when we are talking about the system life cycle. First are people, of course. Why? Because it is the right knowledge, skill, abilities. Do they have everything, which are skills, knowledge? If not, we should train them. Yes, we should schedule the train plane to train them to cover our requirements in stage of knowledge, skills, and abilities. If there is possibility to hire the people which already needed skill set, it's staffing plan. Yes, so if we have idea how we can find the right people at the right time, we should plan the staffing, and it is cheaper for us because we are not wasting time for the training stage, and we are minimalizing the risk that the training will not be a success for each employee. If we are going into the staffing plan, it's a little bit easier because we have the people with already experience. Yes, so the experience will show you if the knowledge, skills, and abilities are good for our business. Second, next one is key stakeholders. and stakeholders involvement plan and artifacts. Of course, when we are talking about the systems, we should always consider the stakeholders which are involvement into the system, and we have to plan all the meetings, all the information flow between the stakeholders and our employees to also think about the possibilities of development of the system and the product. Second is methods. Yes, so we've got the P as people, M as methods. So what are the methods? Proven processes, which are processes tailoring and support stakeholders. So these are the methods which can be used for the proven processes. Next is key events, activities, criteria. So we can use the EMPA, EMSA, SAMP, and SEP. Next one is tools, which is the T in our acronym PMTE. Company standards, if we are able to use already existed company standard, or we have to design the company standard, or we can use the outside standard also. So we should prepare the templates of the standard, enablers, checklist, work instruction, everything which can be useful to creating the management system in our company with the standardization level. We can use also the standards from outside company, including the engineering notebook, reference architectures, normalization, ISO normalization standards. So we also can use those standards. And the last is environment. And environment is the leadership, buy-in, and support, which can be the senior management reviews, or metrics, which is earn value measurement analysis. And the last thing is decision making, which is trades-off, technical performance, measure risk, and opportunities management. Especially the risk and opportunities management should be fundamental when we are talking about the layer of the decision making, because proper methodology of risk assessment will show us all the risk and will show us how we can minimize the risk of our business. And if we'll talk about the opportunity management, probably it is even less often used than the risk assessment, but it is also good to check if new opportunities are shown in environment, because if there is some opportunities, for example for co-financing of our business, we should use it. So it is always good to monitor the risk and opportunities, not just risk. Okay, so we'll talk about the different types of the systems, but after short break. Okay, so let's go through the systems. So these are the main types of the systems. When we are talking about the system engineering, is COS, which is systems that interact with each but were not all intentionally designed to work together, may exhibit unexpected behaviors upon interactions. So these are probably the types of the system which are most difficult to control, but we have to take into consideration that these kind of systems are also existing, and it is much more difficult to control those kind of systems, especially when we are talking about the interoperability of the system, which is the capacity for two or more systems to exchange inputs and outputs across an interface without adversely affecting operational effectiveness and suitability. Another kind of the system is system of interest, which is SOI, and it consists of two types of the system. First up is support system. Second is mission system. And mission system performs the functions that yield results that are operationally suitable and effectively for the user need. When we are talking about support system, it performs the functions that enable the mission systems to complete its operations and execute the mission life cycle defined by the user's need. So it is a little bit similar than I was giving you some example on the life cycle phases of the system, especially when we are talking about the support system. Okay, so guys,